Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide for DTC P2564, which refers to an issue with the Turbocharger Wastegate Control Actuator position sensor circuit showing low voltage. This could affect the vehicle's performance and efficiency, making it crucial to resolve. In Honda CR-V models from 2023 onward, this error can arise due to problems in the actuator, its connections, or the powertrain control module, PCM. The Turbocharger Wastegate Control Actuator is responsible for controlling the flow of exhaust gases to the turbine, regulating boost pressure. The actuator position sensor is integral to this function, ensuring that the PCM receives accurate feedback about the position of the wastegate. If there's low voltage detected, it indicates a malfunction that needs immediate attention to prevent further complications. DTC P2564 indicates that the output voltage from the Turbocharger Wastegate Control Actuator position sensor is below a predetermined threshold. This sensor plays a crucial role in providing feedback to the PCM about the position of the wastegate, which is essential for managing turbo boost effectively. If the sensor's voltage is low, it can lead to poor engine performance and fuel efficiency. The sensor is typically integrated within the turbocharger, making it somewhat challenging to access for direct testing. Therefore, when troubleshooting this DTC, the focus should shift to inspecting the sensor's connections, wiring, and related components, as well as the PCM itself. Several factors can contribute to the occurrence of DTC P2564. A faulty turbocharger can lead to inaccurate readings from the wastegate actuator position sensor, causing voltage discrepancies. Additionally, damaged wiring connections, either due to wear and tear or external damage, may also result in low voltage readings. It is also possible that the PCM itself may be malfunctioning or not processing the signals correctly. Each of these potential causes needs to be examined thoroughly during the diagnostic process to accurately identify the root issue. Understanding these possible causes helps in streamlining the troubleshooting steps involved. Symptoms associated with DTC P2564 often manifest as a noticeable reduction in engine performance, particularly during acceleration or when under load. Drivers may experience issues such as turbo lag, where the vehicle takes longer to respond due to improper boost levels being generated. Additionally, the check engine light will likely illuminate, alerting the driver to an existing fault within the engine management system. These symptoms can influence not only drivability, but also fuel efficiency, leading to increased operational costs. Thus, recognizing these signs early is critical for timely and effective maintenance. In the first troubleshooting step for DTC P2564, begin by turning the vehicle to the on mode without starting the engine. Use the HDS, or Honda Diagnostic System, to monitor the EWG voltage from the WIFT sensor. If the displayed voltage is lower than 0.16 V, this confirms the failure has been duplicated. This step is crucial as it serves as a preliminary check to establish whether the problem is indeed present, allowing you to advance further into the diagnostic process. If the voltage is within range, further inspections of the wiring and PCM may be necessary. The second step in troubleshooting DTC P2564 involves disconnecting the turbocharger connector, which has 5 pins. Once disconnected, inspect the output voltage of the Turbocharger Wastegate Control Actuator position sensor while the vehicle is in the IG mode. The expected output should be around 5.0 V. If the output is normal, it indicates that the wastegate sensor itself is functioning correctly, redirecting focus toward potential issues within the turbocharger or its connections. On the other hand, if the output deviates from this voltage, you may be dealing with an internal fault in the turbocharger assembly. In the third step, it is essential to disconnect the PCM connector E, which consists of 80 pins, to perform further diagnostics. With the turbocharger connector still disconnected, check for open circuits in the VCC2 wiring. You are looking for a reading of less than 1 ohm. If the reading is significantly higher, this indicates an open wire condition that could impact sensor performance. Furthermore, conduct a DCWGL circuit inspection by assessing if it shows more than 1 megaohm to ground. Either of these conditions could indicate issues that contribute to the low voltage signal at the actuator position sensor. The fourth step requires a thorough assessment of the PCM based on the results of previous inspections. If all other inspection items have been deemed normal, it likely indicates that the PCM is at fault. The PCM is the central computer that manages engine performance by processing sensor information and controlling various engine functions, including boost management. If diagnosed as the culprit, replacement or reprogramming of the PCM may be necessary to resolve the issues signaled by DTC P2564. Always ensure that final system checks are conducted post-repair to confirm the integrity of the system. Following the corrective actions for DTC P2564, it's essential to perform a final repair verification. Start by testing the functionality of the turbocharger and the associated actuator position sensor to ensure they are operating as designed. After confirming the repairs, clear any stored DTCs and conduct a retest to see if they return. Observe the engine's performance during this test. Improvements in acceleration and responsiveness should be evident. If the check engine light does not reappear and no further issues arise, this suggests that the repairs have been successful and the system is back to optimal performance. To prevent the recurrence of DTC P2564, engage in regular preventive maintenance measures. Conduct inspections on the turbocharger periodically, as wear and tear can lead to sensor failures. Additionally, monitor electrical connections related to the wastegate sensor for signs of corrosion or damage, which can disrupt voltage readings. It's also important to keep the PCM updated with the latest software versions, as updates may address known issues and enhance performance. Following these proactive steps effectively minimizes the risk of future DTC occurrences, ensuring reliable vehicle operation. In conclusion, addressing DTC P2564 requires a comprehensive understanding of related components, such as the turbocharger, wastegate actuator position sensor, and the PCM. Systematic troubleshooting must be followed to accurately identify the source of the problem, which may range from wiring issues to PCM malfunction. Effective repairs can restore vehicle performance and efficiency. Once repairs are completed, verifying that all systems are functioning as expected is imperative. Adopting preventive maintenance practices also plays a vital role in minimizing the chances of future faults. By being proactive and thorough, vehicle reliability can be significantly enhanced. Please like and subscribe to the channel. See you next time.